A recurring decimal is a number where its decimals begin to repeat at regular intervals. So what we can see here for 1.2415 is the start of the repeating process begins at the 4 and it finishes at the 5 before starting again. So what you're really going to see is 1.2415, 415, 415, and that just continues on forever. Now in this topic, what we're going to do is figure out a way to turn numbers like this that go on forever into a simple fraction. So the number we're going to start with is going to be 0.5 recurring. Now for all of these problems, what we're going to do is use these numbers over here on the right, a 10 or a 100, which is 10 squared, or 10 cubed, which is 1,000, or 10 to the power of 4. Any of these numbers, or maybe it's going to be 10 to the power of 5 or 6, are going to help us in solving these problems. For the first one, what we'll do is simply use 10, and we'll see if that solves the problem. If it doesn't, we'll move on to 100. So over here, what we're going to do is say that x equals 0.5555 recurring. That's our original value here, and we've just assigned it to the letter x. Now what we're going to do is use this number 10 over here. We're going to say, I want to make x 10 times larger. So what we're going to do is multiply x by 10, and you're going to get 10x. Now you have to do the same thing to the right-hand side. So when you times a recurring decimal like this, or any decimal, by 10, what you do is you bounce everything up to the left once. It all becomes larger. So what we're going to do is just move all of these 5s up one space. We're going to get 5.5555 recurring. Now you might see this special pattern taking place here with these numbers. What we've got is a 5 above another 5 and another 5 above another 5. And that's a really good thing because what we're about to do is cancel everything out. What you can do is use subtraction. So here we've got 10x, and if we say 10x and we take away what's above it, that's another x here. So 10x take away what's above it, so 10x take away x gives you 9x. Now if we move back to the right hand side, we'll do the same thing. 5 take away what's above it. Now that's another 5. So 5 take away 5 gives you nothing. And this 5 here, take away that one's going to give you another 0, another 0, another 0, and they're all cancelling out, which is awesome. So what we're going to do lastly is this 5 here takes away what's above it, which is 0. So 5 take away 0 gives you 5. So what we're left with is 9x equals 5.000, and that keeps going on forever, but we don't really care about zeros, they mean nothing. So what we're going to do is write this down as 9x equals 5. So what we've done is we've moved from this value, which was 0.5 recurring, it went on forever, and we've simplified it down to this very, very simple equation of 9x equals 5. Lastly, what we need to do is just find the value of x. So I'm going to divide the left-hand side by 9. The reason I'm doing that is I've got 9 times x, and I don't want 9 times x, I just want x. So I need to get rid of 9 times, and the opposite of 9 times is divided by 9. And if I do that to the left-hand side, I've got to do it to the right, so I've got 5 divided by 9. And what we end up with is these values cancelling out. And we've got x equals 5 over 9. So I'll just write that here. X equals 5 over 9. Now lastly, before you finish any of these problems, you need to check your answers. So what you can do in the calculator is, well, 5 over 9 is the same as 5 divided by 9. So I just want you to type 5 divided by 9 into a calculator and make sure you get 0.555 recurring. For this question here, what we're going to do is use 1.256 recurring with the 5 and the 6 both repeating continuously. So the number we've got is x equals 1.2565656, and that continues. Once again, we're going to look over to the right-hand side, and we have to choose, do we multiply it by 10, 100, 1,000, or a million, or something like that? We'll start with the 10 and we'll see what happens here, because it's a lot easier to solve these problems if you understand exactly what happens when you choose the wrong one. So we're going to try 10. You'll see it doesn't work, and I'll show you why. If I multiply both sides by 10, well, x is going to become 10x. And over here, if you multiply this side by 10, you essentially shift everything up to the left once, or if you like, you can think of it as moving the decimal down to the right once. So the decimal goes into here, between the 2 and the 5, you get 12.5656. So I'm just going to do that now. We're going to get 12.565665, those dots there. Now, in that last problem, we had all of those 5s lining up above and below each other, and I could say 5 take away 5 gave me 0, 5 take away 5, 5 take away 5, and we got all those zeros along the base, and that was great because when you cancelled them out, you ended up with your fraction. Well, here you can see that 5 take away 6 is not going to give you 0. And same with that next number, 6 take away 5 is not going to give you 0. We're going to end up with a whole bunch of numbers which continue infinitely. We haven't solved our problem. Multiplying this whole thing by 10 didn't give us our solution. So we're going to try now, not 10, I'm going to try 100 instead. So I'm just going to erase this number here. What we're going to do is multiply by 100 instead. So x is going to become 100x. So here is 100x equals. Now, if I times this by 100, our decimal shifts down not one bounce, but 2 bounces, because 100 has got 2 zeros on it. So we have 2 bounces down. So what we get is 125.656. So let's just line up our decimals. I need to get 125 there. So 125 point, and we said it was going to be 65656. Okay, now we're cooking, because what you can see is we have a 6 and a 6, one above the other. 5 and a 5, 6 and a 6, 5 and a 5. So I'm going to use subtraction once again. 6 take away 6 is 0, 0, 0, 0, 0. 5 take away 5, another 0. Now here we have one tiny problem, but we're going to fix that in a second. 6 take away 2 is going to give you 4. We have our decimal. 5 take away 1 gives you another 4. And then we have 1, 2. So we've got 124.4. And that leaves us over to the left-hand side. We've got 100x take away x. Well, that gives you 99x. So what we've got now is 99x equals 124.4 with all those zeros going off infinitely. But once again, those zeros mean nothing, so we can just ignore them. So just to make this neater, we have 99x equals 124.4. So what are we going to do with that? Well, we have this decimal, and I want to get rid of that. So how can you easily get rid of a decimal? Well, you can just times everything by 10. So I'm going to say times 10 on the right-hand side and times 10 on the left-hand side. Make everything 10 times bigger. That gets rid of that decimal. So 99 now becomes 990x. And 124.4, we're going to bounce that decimal down over to here. We're going to get 1244 with our decimal there now. So there's our new equation, and now we just need to bring the 990 over to the right-hand side. So we've got 990 times x. What's the opposite of 990 times? It's going to be divided by 990. So divide by 990, divide the right-hand side by 990 to keep things fair, and now we can cancel things out. So what I've got is 990 divided by 990, they cancel out, and you're left with the x. So we've got x equals 1,244 divided by 990. X equals 1,244 divided by 990. Now at this stage, if you like, you can test this to make sure you're not wasting your time. If you take a calculator and type in 1,244 divided by 990 equals, you should see you get 1.25656 recurring. That means you've got the solution you want, but we can simplify our fraction, and in most questions you need to simplify your fraction if you want to have the correct answer. So how can we simplify this? Does 990 go into 1,244? It does. It goes in once, and you should be left with 254 over 990. And you can take that even further because we've got these even numbers here. So we're going to pull out the 2's out of both the top and the bottom, or the numerator and the denominator. We're going to get 1 and 127 over 495. Typing that into a calculator as a fraction and pushing equals will often simplify that for you anyway. Once again, you can type this into a calculator and make sure that you get 1.256 recurring. So that's our second example. For this last problem, we're going to look at 0.3517 recurring, with the 5 and the 7 being the start and the end of that repeating process. So what we've really got is x is equal to 0.3517517. You can see the dot above the 5 and the dot above the 7. That indicates start at the 5, finish at the 7, start again. So How can we solve this? Well, we'll just quickly start with the 10. See if multiplying both sides by 10 will fix the problem. So I'm going to get 10x over here on the left-hand side. And we remember that simply bouncing everything up once, we're going to get 3.517517, and you can see straight away these numbers aren't cancelling each other out if we subtract them. We're not going to get zeros, which is what we need. So what I might do is quickly erase that, and we'll try 100 and see if that fixes the problem. Okay, multiplying by 100, what we're going to see is 100x equals, now if we bounce things down not once this time, but twice, because 100 has two zeros, we're going to end up with a decimal between the 5 and the 1, so we get 35. So 35 point, and a lot of the time just make sure you place your decimals down first, because you'll make sure you line everything up perfectly. So 35.175175. So 175. I really don't think that is fixing our problem. You can see we don't have anything cancelling out there. Once again, didn't help. Let's try 1,000 and see if that fixes it. Okay, last one, we're timesing by 1,000. Bounce the decimal down 3 times because we have 3 zeros. So our decimal is going to end up going once, twice, 3 times. It moves in between the 1 and the 7. So what you're going to get is 1,000 x's. So 1,000 x equals, remember to place your decimal down because we're going to be squeezing quite a lot of stuff in here. We get 351. So 351.751751. 7, that doesn't match up. But look at this. 51. 751. 751. 7. That works. So what we've found is that multiplying by 1,000 gets us our numbers that's going to cancel each other out. So why does that work? Why do we multiply by 1,000? And are we going to do this every time we have a question? Are we going to start multiplying by 10, by 100, by 1,000, by a million until we solve it? No, you don't have to do that. Here's a trick. You can see that we've got 517. The repeating takes place across 3 numbers here. You can see the same 3 numbers here for 517, and again 517, 517. So it repeats every 3 numbers. How many times did I have to bounce our decimal down to get the repeat cancelling out? We'll go back over here. When we tried bouncing it down once, that didn't fix it. So we tried twice. That didn't fix it. We tried this one here. That's 3 bounces because you got 3 zeros. Come back to this one here. How many numbers do we have to bounce down? We've got 3. This 3 keeps occurring here. You can see we've got 3 numbers. So what you need to do is pick the number that's going to shift everything down, the equivalent number of repeats. So 517 is the length of that repeat. So we choose 1000, 1000. So let's just finish this off now. All those numbers cancel out. We're going to get 0, 0, 0, 0, 0, 0. And 7 take away 3 gives you 4. 1 take away nothing is still 1. Not 1,000. What's 1,000x take away x? That's going to give you 999x. All right, so we're just going to turn this thing into something a little prettier. What we're going to see is 999x equals 351.4. And how do we get rid of that decimal? Well, just like we did over here, we times it by 10. It shifts everything down once. So times both sides by 10. I'll just write that here so we can see what we're doing. Times 10 to both sides, and you're going to end up with 9,990x equals 3,514. Last of all, how do you get rid of 9,990 times on the x there? Well, you divide it by 9,990. So divide both sides by 9,990. Divide that side by the same to keep things fair. And we can see we've got our cancelling out occurring there. 9,990 cancels with that one there. And we end up with x equals, so we can see we've got our x still sitting there, x equals 3514 over 9,990. And if you place that into a calculator, it'll probably simplify it for you if you push equals. Otherwise, you can see that we've got these even numbers on the top and the bottom, so you know that 2 will come out of this. We can divide the whole thing by 2. you'll see that our fraction simplifies down to 1757 over 4995. Last of all, do we stop there? I wouldn't. What I'd do is I'd test it. So with the calculator, type in 1757 divided by 4995, press equals. Do you get 0.3517, 517, 517? Yeah, you do. So we know we've got the right answer, and we can say, yep, we're right.